We just finished studying the discovery of the atom. We ended our discussion with the Bohr model, which is not the currently held model of the atom, but it is a convenient one to study because of its simplicity. We see that in the middle of the atom is the nucleus, which contains two different types of subatomic particles. There are protons, which have a positive charge and a mass of 1 atomic mass unit. Also in the nucleus are neutrons, which have a 0 charge and also have 1 atomic mass unit. Orbiting the nucleus are the electrons, which have a negative charge and such a small mass that their mass is effectively 0. The atoms are organized into the periodic table of elements, which you are undoubtedly familiar with. There is lots of information contained in this table. Some of the information we can find is the name of the elements, the symbols of the elements, the atomic number or the number of protons in each element, as well as the atomic mass, which is not important for right now, but we'll discuss it later. We identify atoms based on their atomic number or the number of protons in the atom. This atom contains 7 protons. 1, 2, 3, 4, 5, 6, 7. In order to identify the atom, we need to look at the periodic table. We see that nitrogen has an atomic number of 7. Therefore, it contains 7 protons. Let's practice identifying a few atoms using the periodic table. This atom contains 3 protons. Using the periodic table, we can see that lithium has an atomic number of 3, therefore meaning that it contains 3 protons. How many protons would you expect to find in a silver atom? Using the periodic table, we locate silver and see that it has an atomic number of 47. Therefore, meaning that we would expect to find 47 protons in a silver atom. This is a representation of the nucleus of an atom. The red balls represent the protons, while the gray balls represent the neutrons. We see that this particular nucleus contains 6 protons. Using the periodic table, we notice that carbon has an atomic number of 6, so we would identify this nucleus as a carbon nucleus. If we look at this nucleus, we see that it also contains 6 protons. Is this also a nucleus of a carbon atom? We can see that the two nuclei are clearly different. They both contain 6 protons, but the one on the left contains 6 neutrons, while the one on the right contains 8 neutrons. These two atoms are called isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. One thing that differs about isotopes is their mass number. The mass number is equal to the number of protons plus the number of neutrons. 6 protons and 6 neutrons yields a mass number of 12, because each proton and each neutron has a mass of 1 atomic mass unit. The nucleus on the right has a mass number of 14. These can be represented in different ways. We use the element symbol, the mass number, and the atomic number in order to represent an isotope of an element. We see that the representation on the left is different from the representation on the right, but it differs by only one small factor. We see that the mass number of the atom on the left is 12, while the mass number on the atom of the right is 14. Otherwise, the atomic numbers are the same because both atoms contain the same number of protons, and the element symbol are the same because the identity of the element is determined by the number of protons. Atoms that are neutral have a charge of 0. In order to have a charge of 0, they must have an equal number of protons and 2 electrons. Here we see 5 protons and 5 electrons. The positive and negative charges balance each other out, leaving a net charge of 0. However, not all atoms are neutral. Some atoms exist as ions, which are atoms with a positive or a negative charge. In order for an atom to be an ion, it must have a different number of proton and electrons. For example, here we see 5 protons and only 2 electrons, leaving a net charge of +3 because of the fact that there are 5 positive charges and only 2 negative charges. Let's practice with ions. The atom pictured above has a nucleus that contains 11 protons and 12 neutrons, which you can't see based on the picture. But you could count the number of red dots and see that there are 11 electrons. Based on this, we know that the charge is 0 because the 11 protons have 11 positive charges, the 11 electrons have 11 negative charges, which mean the positive and negative charges cancel each other out, leaving a charge of 0. If this atom loses 1 electron, that doesn't change its number of protons and neutrons, but it has 1 fewer electron. Therefore, this atom will have a charge of +1 because there are 11 positive charges but only 10 negative charges. We could determine using the periodic table that this is an atom of sodium. We know that it's sodium because it contains 11 protons, and we can identify sodium based on its atomic number of 11. Therefore, the atom on the left is a sodium atom because it has a neutral charge. We could represent it by just writing its symbol, Na, or we could use the notation that we saw earlier, showing the mass number on the top left, the atomic number on the bottom left, and the charge on the top right. The atom on the right-hand side is a sodium ion. We can represent it by writing Na+, which means a sodium ion with a charge of +1, or we can represent it using the notation we saw earlier with the mass number on the top left, the atomic number on the bottom left, and the charge on the top right. Notice that there is not much difference between the notation of a sodium atom and a sodium ion. The mass numbers are the same and the atomic numbers are the same. The only difference is the charge. The sodium atom, which is neutral, has a charge of 0, while the sodium ion has a charge of +1.